Alright, let's start. Let's look at exercise 17.2, question 16. Sorry. Oh, homework, sorry. Please pass it up now. Yeah. Oh, you went through already, right? Okay, submit your 16.2. The blazer, right, this one is size L. I think I was given the wrong one. I'll go exchange it then. After school, can you come to see me? Take your blazer. Okay, submit your homework to the front. Please submit homework, please. But it's very hard. Speak for more. Nine only. Boy. What do you know about the boy? Please remember today the real context is due, so please submit to this down, otherwise to my locker before 5 o'clock. If you have any problems with submission for the assignment, okay, let's get back to this question. Could we start? Alright, we are given this equation y equals to e to the power of x minus 2x minus 1, and we want to find the minimum value, we want to find the value of x such that we will get a minimum for the value of y. Okay, so how should we go about doing it first? What should we do first? I will differentiate it. Okay, so the first derivative will be e to the power of x minus 2. Okay, then after that, since you're looking for minimum value, what do we have to do with this? It will be equals to 0. Then we can apply logarithms on both sides. Okay, so x is equals to log 2. Okay, is this all for the answer? No. What else do we have? Minimum. Okay, we have to check for the minimum. Alright, so I have to do the second derivative. And that will be e to the power of x. Okay. Then after that, when x is equals to log 2, we find that the second derivative equals to 2, which is more than 0. Therefore, y has a minimum value when x equals to log 2. Okay? Yep.
We have to put
equals to 2.
Because you already proved.
You can at least substitute x to belong to. At least do that. Yeah.
When did you say dy dx equals 0 then? Then you explain that more than
That statement, you can always write it. Okay, if you don't write it, it is also fine as it is. Yeah, because you're using the second derivative test. Okay. So there's nothing wrong with writing more, but if you don't write it, I guess it should be fine. Okay. Alright, anyway, yesterday you were asking me about why the derivative of e to the power of x is equals to e to the power of x. I went to Google, okay, and then I found a Khan Academy video, but I somehow can't understand, okay, despite it being from Khan Academy. But if you wish to understand and you think you can understand, okay, you can go to the video and then I'll put a link over there, okay, for those that are curious, alright?
Link in the description below.
Yes, link in the description.
Just point out.
Yes, I know. I purposely made that pun.
Huh? So you actually?
Yeah.
Oh, so you're becoming so joy. That's bad.
Okay, so part 2, we want to calculate this minimum value. So when x is equals to ln 2, okay, your y will be equals to e to the power of ln 2 minus 2 ln 2 minus 1. So that will give you 1 minus 2 ln 2. Okay, you can leave your answer in exact, otherwise in 3SF is also fine. Okay? Oh yes, that's fine. Okay, anything equivalent. Okay, part 3. We want you to find a set of values. We want to find a set of values of x for which y is actually increasing. Okay, so I noticed that when it comes to doing this kind of proofs, right, as I was marking your 15.2, okay, it seems like you struggle with the difficulty in understanding what are the things that are given and also what are the things that you need to find. Okay, very often I see that the structure and the flow is actually the other way around. So when I return to your 15.2, I will run through that again. Okay, then after that, so for part 3, right, finding the set of values of x for which y is increasing. So can you tell me what is the given information? That y is increasing, right? Okay, so this is the given information, and what you want to find is the set of values of x. Okay, so when you do any questions as you practice for 15.2, okay, or doing any proof kind of questions, I think it will be a good practice for you to identify, okay, what are the given information and what is it that you want to find, okay, before you jump straight into the question itself. So in this case, given that it is y is increasing, so that means that dy over dx will be what? More than 0, right? Okay, so this means that our e to the power of x minus 2 will have to be more than 0. Okay, then after that, in this case, that means e to the power of x will be more than 2. Okay, and then after that, x will have to be more than ln 2. Okay, so how this happens is that for this inequality, you can let it be equals to 0, then after eventually, when you do your logarithms, you see that x will be equals to ln 2. Okay, so but for this whole expression to be more than 0, you will have to notice that x has to be more than ln 2. Okay, or otherwise, you could see it as so-called being able to apply ln on both sides, the inequality will still maintain. Okay, sorry. Ln 0 doesn't have anything right here.
Second derivative. If we actually do that, okay, use dx less than at 1.
Dx e to the power x will be more than 0 regardless of what values it is. Okay, yeah.
Read so part 2, right? Is it better to leave it exact or not?
Either will be fine. Yeah. Unless of course the question asks for exact, then your part 2 usually be exact. Okay? Right, part 3, any problems? You understand what I was saying? Okay, so in this case, x is more than ln 2, that will be the set of values. Okay, you can evaluate ln 2 to give the decimal 3SF, that is also fine. Otherwise, you leave it in exact ln 2, it is also okay. Yeah, that's all. Okay, next, we look at question 18.
I read waves and CPU and I applied. And then first I read that
Yep. Okay, let's first look at question 18, part 1 and 2. Okay, so part 1 is straightforward. We have seen such questions when we do exponential questions. Okay, at beginning of 2006, that means what do I have to substitute? T equals to 0. Because T is being defined as the time after beginning of 2006. Okay, so when T is equals to 0, okay, we find that P will be equals to 650,000, not equals to 1. Okay, so that is the population. So part 1, I think it should be manageable. Okay, part 2, alright, that is a bit of a challenge in understanding the question. Okay, we want to show that the rate of increase, which is dp over dt, okay, it is directly proportional to the population at time t years after 2006. So we want to show that dp over dt is directly proportional. Remember, this is our directly proportional sign, okay, to the population p. Okay, so what do we understand about direct proportion?
When one increase, the other one also increase.
Okay, then what is the equation that we usually show when we say that y is directly proportional to x?
Y over x.
Y equals to kx, right? Okay, so in this case, if I want to have rate of increase to be directly proportional of p, okay, in order to show it, that means that I must have an equation dp over dt equals to some constant k times the population. Okay, so I must be able to show something like that, that there is such an equation being fulfilled. You understand what I'm saying? Okay, so therefore, in order to go about doing this, okay, I need to first find out what is dp over dt. Okay, so given the equation over there, I can do the differentiation to find dp over dt. Okay, so differentiating the exponential, it remains the same, but don't forget to differentiate mt. Okay, with respect to t, that will be equals to m. So I will be getting 650. So I'm getting 650,000 e to the power mt. And this part itself, that is none other than p that was originally given, right? So therefore, okay, you can do the substitution. So that means that it is P times M. And M is a constant, okay, you can also see as M times P. Alright? So since M is a constant, we see that there is a direct proportion. So since M is a constant, dP over dt is directly proportional I suggest not, in case you anyhow write. Okay, just write in full words directly proportional. Because actually by right the symbol T should be written like that, right? Any questions understanding this? Okay. Sorry? Yes. Yeah, in years. Yeah.
Not in users, but
Write this one up. Oh no, you don't need to write the things in red. Okay? In presenting the answers, then you just write the things in blue. Okay? Next for part 2, part 3. If the population of the city is 25 years, T is in years by the way, okay, years after beginning of 2006, we want to show that this equation will be fulfilled. Okay, so therefore, in order to do this, we use the first information that is 25 years later. Okay, so T is also given to be 995,000. So just simply do the substitution. Okay, so 25m will be equals to ln 199 over 130. Take note that the thing that you want to show is that there's a difference in logarithm. That's where your logarithm laws come into play. Okay, so you would have shown the equation.
I also use the N.
Sorry?
It's supposed to go to 0 or something. No.
Huh? What?
The one like the 0 opposite. No, the one like the N. The part 4, I also use N.
Part 4, yeah, you're supposed to use that.
So estimating this. I think like first you can actually find the exact answer. Not exact for the small part.
Because you want to correct to the nearest answer. I guess that's why it's not an estimate. And also this is a model, that's why it's an estimate. Yeah. Okay, so in part 4 we want to estimate the population after 30 years.
Oh my god, this is.
Okay, giving your answer correct to nearest thousand. Okay, so in order to find this estimate, the reason why the question says that estimate, okay, that is because I believe the equation given to you, it is supposed to be a model, okay, so therefore it can only be an estimate. You will not be able to find the exact thing, okay. So ideally that's not the point of the question. The question just wants you to find after 30 years, meaning t equals to 30, okay, what is the value of p? So to use the m value, okay. For the m value, we will substitute using what we found in part 3.
Jadi kan, so over 30.
Huh?
So over 30 years.
What thing 30 or 25?
And it's at 25 years and it's at 30.
Why? Is there an issue?
Other thing, right?
Okay, then you press into calculator, you will get this value. This question wants you to round it to nearest thousand.
Oh my god.
Okay, there's 2 more parts to this question. So part 5 wants you to find the increase in population from 2014 to 2015, giving your answer correct to nearest thousand. Okay, so how do we find the increase in population? What should we do first? Huh? Differentiate. Okay, we just have to find the population in 2014 and then also find the population in 2015, right? Okay, so in 2014, how do we find the population?
14 minus 6. 8.
T is equals to 8. Okay, so P will be equals to 650,000. Then E to the power of M, that would be,
Log 199 minus log 130 over 25.
hang on now. Okay, let's not substitute M inside, okay, to keep things neat. So 2014, okay, we can put 8M. Then after that, in 2015,
Equals to 9.
T is equals to 9, so P will be equals to 650,000 E to the power of 9M. Okay, the reason why I want to keep M to itself, right, rather than putting the entire value in, is because you try to find out what is the increase in population. So that will be the difference. 650,000 E to the power 9M minus will be 650,000 E to the power 8M. We can do a factorization. Okay, it doesn't cancel out, but you can just directly press the calculator after that. So you will have ln 199 minus ln 130 over 25 times e to the power ln especially some of you with very bad handwriting. You keep on writing, okay, end up I will not be able to see where's the answer. So in this case, you will get 13,000 when you rounded to the nearest thousand.
So maybe I would prefer writing it at the start and do a formula. Then minus it to exact numbers.
Huh?
Then sub m at the start. After they get to exact numbers.
Or and you get exact numbers. Anything up to you decide. So you find that the previous two parts, they are just your usual questions, okay, doing substitution, doesn't require any differentiation. Right, I want to look at part 6. Okay, we want to estimate the value of t for which the rate of increase in population first exceeds 18,000. So you want the rate of increase to exceed 18,000. Rate of increase in population, that refers to your dp over dt. Exceeding 18,000 would mean that it's more than 18,000. Okay? And in this case, this is the given information because we want to estimate the value of t. Okay, the value of t is what we want. Okay? So, in this case, dp over dt, we have already found it previously. Okay, so previously in part 2, we have already found out what is dp over dt, which is 650,000 m times e to the power of mt. Okay, and then since now we want to know that it's more than 18,000, so let's just find it such that it is equals to 18,000 first. Okay, we equate it into 18,000 so as to do our algebraic manipulation easily. Okay, so e to the power mt will be equals to 9 over 325 m. Okay, then after that, to find out what is mt, you can do your logarithms. So 1 over m would be 25 over ln 199 minus ln 130. Okay, then substitute in your value of m, press into calculator the entire thing. You will get about 28.544. Rounding it off, that will be 28.5. Okay. So the value of t for which the rate of increase first exceeds 18,000, okay, that will be at about 29 years after the beginning. So in this case, Okay, we round